Okay, so this is Ksp Practice Problems 2, and this is just further review of your homework for tonight. So we're going to be looking on Interactive Notebook page 14, and you have a worksheet. In the previous video, we talked about some of these problems on the back of the worksheet. Now we're going to be looking at this side. So this is chemistry worksheet solubility. There's a couple things I want to point out. There's some scratch work on here. This is an old copy of a worksheet. Ignore the numbers that we have here. The answers that are given to you are correct. So we're going to be looking at a couple of problems today. Remember, if you're not familiar with KSP and setting up KSP, you need to go back to the first video so you can learn how to set up KSP equations. All right, the first problem that we're going to look at on the worksheet is problem number 5. And problem number 5 says, the solubility product for AgCl is 1.8 times 10 to the negative 10. Calculate the molar solubility. And so we know that our KSP equation is going to be KSP equals, and we have to set it up. Well, it's AgCl. So I know that that's just going to be Ag times Cl. And so when I plug x in for both of those, KSP is going to equal x times x, which is x squared. So I have to see which side of the equation I'm working on. Well, I want to calculate the molar solubility. Molar solubility is another way of saying x. And the other way I know this is it gave me the solubility product constant, or the KSP. So I'm going to plug 1.8 times 10 to the negative 10 in for KSP, and I'm going to solve for x. So I'm going to go ahead and set that up right here. So under KSP, I'm going to put 1.8 times 10 to the negative 10 equals x squared, and I'm solving for x. Well, how do I solve for x whenever it's in this situation? I'm going to take the square root of both sides. So I'm going to take the square root of both sides, and my answer is going to be x equals whatever the square root of 1.8 times 10 to the negative 10 is. So I'm going to type that into my calculator. 1.8 times 10 to the negative 10, and then I'm going to take the square root of that, and I get 1.34, and that's 5 decimal places back. So 1.3 times 10 to the negative 5, and that'll be my answer for KSP. I'm sorry, my answer for x. My answer for x, because I plugged in 1.8 into my spot for KSP. So my molar solubility, or x, equals 1.3 times 10 to the negative 5. Okay, so let's look at a different practice problem. Let's look at problem number 8. Problem number 8 says the solubility of CuOH2 is 1.8 times 10 to the negative 7. What is its KSP? Okay, well in this problem it's a little bit different because I'm solving for KSP and they've given me the solubility, or the x. I'm still going to need to set it up, but I'm going to be solving for KSP this time, plugging this in for x. Okay, so KSP equals, well, CuOH2, I know that that's going to break into Cu and 2 OH's squared. When I plug x in for that, it's going to be x and 4x squared, which gives me 4x to the third as my KSP. So KSP is going to equal 4x to the third. I'm going to plug 1.8 in for x and then solve for KSP. So I'll move over here to the other side to do that. KSP is going to equal 4, and then I'm going to plug this in for x cubed. Now my PEMDAS rules tell me that I'm going to have to deal with this before I can deal with this. In the previous video I showed you 2 ways that you could do this. You can either type 1.8 times 10 to the negative 7 into your calculator and hit cube, or you can break it up and you can cube 1.8 and then multiply negative 7 and 3. And so that's what I'm going to do here, since some of your calculators can't handle it. I'm going to type in 1.8 and I'm going to cube it, so times 1.8 times 1.8. So I get 5.83. So I have 4 times 5.83 times 10 to the, well, negative 7 times 3 is going to be negative 21. So I'm going to now multiply that by 4, and I get 23.3 times 10 to the negative 21. I know that that is not set up in the right format because this is not between 1 and 10. So I'm going to move it up 1 and I add 1. I get 2.3 times 10 to the negative 20, and that is my value for KSP. Okay, again, I plugged it in and I took 1.8 to the third power. It gave me 5.83. Then I had to do negative 7 times 3, and I got negative 21. multiplied 4 times 5.83, and that gave me 23.3 times 10 to the negative 21, but in order to get it in the right format, I had to move it back 1 and add 1, and so I got 2.3 times 10 to the negative 20. Okay, let's look at number 3. Number 3 says the solubility of VaSO4 at 25 degrees Celsius is 3.9 times 10 to the negative 5. Calculate the Ksp. It's asking me for the Ksp. It's giving me molarity, which is my concentration. So I know that Ksp is going to equal, all right, BaSO4. Well, let's think. Ba is barium plus 2. SO4 is sulfate negative 2. So that means I'm going to have just one Ba and one SO4. So it's just going to be x squared, because it's going to be x times x. So Ksp is going to be x squared. I know that I'm solving for Ksp, so I'm going to plug 3.90 times 10 to the negative 5 in, and I'm going to square it. Now remember, I can type this into my calculator and hit square, or I can break it up, 3.90 squared, and then times 10 to the negative 5 times 2. Okay, which is what I'm going to do, and then I'll deal with the decimal. So 3.9 squared, so times 3.9, gives me 15.21 times 10 to the negative 10. Negative 5 times 2 is 10. I know this isn't in the right format. It's too high, so I'm going to add 1, and I get 1.5 times 10 to the negative 9 as my answer. And so my Ksp is going to be 1.5 times 10 to the negative 9. Okay, 2 more problems that we're going to go through pretty quickly. And the next 2 problems we're going to look at is we're going to look at problem number 1. Now, problem number 1 is probably the most difficult problem on the worksheet, and it's only because you have to really pay attention to what they give you. Okay, it says solubility of PbCrO4 is 4.3 times 10 to the negative 5 grams per liter at 25 degrees Celsius. Now remember, they just give us temperature because solubility changes at different temperatures. The standard temperature for solubility is 25 degrees Celsius. Calculate the Ksp. So I'm going to be looking for Ksp, and they've given me X, but not quite. Do you see how they've given it to me in grams per liter? Well, that's not actually the right format. We need it to be in moles per liter. So I'm going to have to turn grams into moles first. And so that's going to be my first step. So I'm going to do that over here. 4.3 times 10 to the negative 5 grams of PbCrO4. Okay, so I'm going to have to do grams to moles. Well, I know that 1 mole is going to equal the mass of PbCrO4 on the periodic table. So when I look up Pb plus Cr plus 4 O's, I get 323.2 grams. And again, that's adding up the mass of Pb plus Cr plus 4 oxygens. And so I'm going to have to take 4.3 times 10 to the negative 5, and I'm going to have to divide it by 323.2. And when I do that, I get 1.3 times 10 to the negative 7. So I'm going to take, so that gives me 1.3 times 10 to the negative 7. And now that is in molarity, because it's already per liter, so I just need to turn gram into moles. So that's my molarity. So that is my X. I need to find the Ksp. Okay, so in order to find the Ksp, I know that Ksp equals Pb and Cr. Well, lead is plus 2, chromate is negative 2, so that's just Pb and CrO4. So that's going to be x squared. So I just need to plug this in for x. 1.3 times 10 to the negative 7. I'm going to square that. And so I need to take 1.3, and I'm going to square that. When I get, when I type in 1.3, and I square that, I'm going to get, it's actually 1.33. I'll get 1.7, and then negative 7 times 2 is negative 14. So my Ksp is something close to 1.7 times 10 to the negative 14. I believe your answer key says 1.8, and that just has to do with how we rounded along the way. So this would be my Ksp. Okay, the only thing different about this one is it was given to me in grams per liter, and it had to be moles per liter. So I had to turn the grams into moles by dividing by its molar mass, which gave me my actual concentration in terms of molarity, or moles per liters. That was the only thing different about this problem. That's what made it a little more challenging. Okay, last problem, problem number 2. Problem number 2 says calculate the solubility product of silver chromate whose solubility is 1.3 times 10 to the negative 4. Okay, so it's asking me for the solubility product constant. It's asking me for Ksp, and it's giving me the solubility, or the X. So all I have to do is figure out what silver chromate is, and then write my Ksp equation. Well, silver is Ag. Ag is normally +1, and chromate is CrO4. It's -2. So I know that my formula for that is going to be Ag2CrO4. Okay, so let's put that into Ksp. Ksp equals, well, Ag2, that means I had 2 Ags. So that's 2 Ag squared, and then CrO4 is just a single polyatomic, CrO4. So when I plug x's into that, that's going to be 4x squared times x, which is 4x cubed. So my Ksp formula is Ksp equals 4x cubed, and I know that the solubility, or the x, is 1.3 times 10 to the negative 4. So I'm going to solve for Ksp by plugging in that value for x. Okay, so 4 times 1.3 times 10 to the negative 4 cubed. Okay, remember, in order to make our calculators happy, we're going to break it up. We're going to do 1.3 to the third, and then we're going to do times 10 to the negative 4 times 3. Okay, so I'm going to say that I know it's going to be 4 times whatever I get by using my exponent. So 1.3 times 1.3 times 1.3 gives me 2.197 times 10 to the negative 12, negative 4 times 3. Okay, now I'm going to multiply 4 times that, and so I get 8.78, or 8.8 times 10 to the negative 12 as my answer. And so you can see that I have multiplied in, I did this to the third power, then I multiplied these, I multiplied the 4 in, and I got 8.8 times 10 to the negative 12 as my Ksp value. Alright, so that's solving for either Ksp or solubility. Make sure that you always pay attention to what you're going to plug into. If they give you the solubility and it's in moles per liter or in molarity, that's going to go in for X. If they are giving you the solubility product constant, or they're giving you Ksp, you'll plug it in for Ksp.